Hi kids, in a previous video, we did the proof for the theorems on angle properties of circle. Even we did exercise 15.1 till sum number 5. Let us continue from sum number 6. Just a recap of the main theorem. First thing, angle at the center, suppose this is ABO, angle at the center is twice the angle at circumference. So if this is x, this will be 2x, isn't it? Angle AOB is twice of angle ACB. Angle AOB is twice of angle ACB. Then we did angle in the same segment are equal, which means if suppose this is a circle, you take AB as an arc, and from here you make angle ACB and you do another angle, suppose ADB. Then since the segment is same, AB, so ADB, angle ADB is equal to angle ACB, angle in the same segment. Then we did one more, which was angle in the semicircle is 90 degree, which means if this is a circle and if AB is your diameter, then with AB, if you draw any angle on any part of the circle, then this angle will be 90 degree. Angle ACB equals to 90 degree, provided AB is the diameter. Okay, look at 6a. They've given this circle, O is the center, okay, which means AB is the diameter. Calculate the value of PQB, this angle they have asked for. They've given PBA as 42. Now look carefully, this one. Angle APB will be equal to 90 degree. Angle at a semicircle. Why? Because AB is the diameter, so this part is a semicircle. So this is 90 degree. Once you get this angle PAB, see, in triangle PAB, angle PAB plus 90 plus 42 is equal to 180. That's angle sum property, isn't it? Which means angle PAB is equal to 180 minus 132. That's how much? That's 48 degree. So this angle is known, 48 degree. Now look carefully. PAB, angle PAB will be equal to PQB. Since the segment is same, angle in the same segment, see, from the arc PQ only, we had PAB, PQB, PB, okay? Which means this is equal to PAB is equal to PQB equals to 48 degree. Angle in the same segment. Angle in the same segment, isn't it? Pretty easy. Just use angle at circumference, then angle at the same segment, you will get the value. Okay. Now let us look at the next sum. Now look at this sum, 6 part B. Trust me, very easy. In this circle, AB is the diameter, O is the center. Angle ECD, which means this angle, and EDC, which means this angle, is given as 32. So this is 32 degree, this is 32 degree. They've asked for CEF, which means this angle, if you see the diagram properly, and COF, this angle. Now just see the triangle CED, something like this, CED. Just look, CED. This angle is given as 32 and this is given as 32. So this angle, look carefully, exterior angle equals to sum of opposite interior angle, which means CEF. Look carefully, in triangle CED, angle CEF is equal to angle ECD plus EDC. Exterior angle equals to sum of opposite interior angle. So angle CEF equals to 32 plus 32. That's 64. Done. So this angle is 64. Now look at part 2. COF. Now if you look carefully, COF, angle COF will be twice of angle CDF. CDF. Angle at the center is twice the angle at circumference. Angle at center is twice angle at circumference, which means angle COF will be twice of 32. That's 64 degree. So both the answers are 64 degree. Clear? Pretty easy. Okay. Now let us look at the next sum. Now look at this one. 7 part A. Pretty easy. There's a circle. AB is the diameter. O is the center. APQ is a straight line. RBQ is a straight line. Angle A is 35. Angle Q is 25. They've asked for PRB, which means this angle. If you look at the diagram, PBR. So we need to join this PBR and BPR, which means this angle, which means all the angles of the triangle PRB. The first one, if you look, very easy. Angle PAB, angle PAB is equal to PRB, same segment. See, PB, PB. You need to look at the diagram properly, that's equal to 35 degree. We write angle in same segment, angle in same segment, isn't it? So this is known 35 degree. Now this angle, how to find? Just look over here in triangle APB. In triangle APB, angle APB will be equal to 90 degree. Angle in a semicircle, see, AB is the diameter, so angle APB with diameter, if you form a angle at any point on the circumference, that will be 90 degree. So APB is equal to 90 degree. Angle at semicircle, angle at semicircle, isn't it? Which means this whole angle is 90. Am I clear? Now this is 90, this has to be 90 because these are linear pair. This is a straight line. Therefore angle QPB is equal to 180 minus angle APB, that is 180 minus 90, that's 90, linear pair, isn't it? Now look at triangle PQB. Triangle PQB. This angle plus this angle will give you this angle. Exterior angle equals to sum of opposite interior angles. So we can say angle PBR will be equal to angle PQB plus QPB. Exterior angle equals to sum of opposite interior angle, done. Which means angle PBR is equal to 90 plus 25, that's 115 degree. So this is 115. Now once you got two angles, the third angle is you can get by angle sum property. Look over here in triangle PBR, angle BPR plus 35 plus 115 is equal to 180. That's angle sum property, which means angle BPR equals to 180 minus T50, 150. That's 30 degree. Done. Nice sum, okay? We used angle in a semicircle property over here. Okay? And angle in same segment. Now let us look at the next sum. Now look at this sum, 7 part B. In this circle, O is the center, AD is the diameter, angle ABC is 40 degree they have given. They've asked for calculate DAC, which means this angle. Pretty easy. If you look, angle ABC is equal to ADC, that's equal to 40 degree. Why? Same segment, isn't it? Same segment. Look, they are both drawn from AC. Okay. Now, once you got this as 40 degree, if you look carefully, AD is the diameter, which means angle ACD ACD will be 90 degree. Angle at semicircle, angle at semicircle, isn't it? So this is 90. Once you get this angle, I think in triangle DAC, angle DAC plus 40 plus 90 will be 180. That's angle sum property. We know this. So angle DAC will be 180 minus 130. That's 50 degree. Pretty easy. We use same segment, angle at semicircle property. Okay. Now let us look at the next sum. Now look at 8 part A. Very interesting. Though the diagram looks complicated. Just look. There are two circles. Given ACD is a straight line. P is the center of this smaller circle. Q is the center of this bigger circle. And angle APB is marked at 130 degree. They've asked for BQD. That's marked as X. Pretty easy. Just look over here. First the smaller circle. Angle APB will be twice of angle ACB. See, the segment is same. So angle at the center is twice the angle at circumference. Angle at center is twice the angle at circumference. We know this, which means APB is 130 equals to twice of ACB. So that's 65 degree equals to angle ACB. Done. So this angle is known 65. Now look carefully. DCB will be 180 minus 65. Linear pair. That's a straight line. Angle DCB equals to 180 minus 65. That's linear pair. Which means angle DCB will be 115 degree. So this angle is known 115 degree. Now look carefully. Angle DCB and reflex DQB. This angle, this part, has a relation. What? Angle at the center is twice the angle at circumference. See, with BD as an arc, we are drawing those two angles. So we can say angle B reflex angle BQD will be twice of BCD. See, the segment is same. One is at the center, the other is at the circumference. So that the center one will be twice the angle at circumference. This reason comes over there, which means reflex angle BQD is equal to twice into 115. That's 230 degree. So this is 230 degree. Now the last part, X plus 230 degree will be 360. Angle at a point. Angle at a point is 360, which means X will be 360 minus 230. That's 130 degree. Very easy. Just look at the sum properly and use the theorem. You can solve it very easily. Clear? Don't be confused with this and this. They don't have a relation. This angle and this angle, I'm talking about, see, angle at the center, will be twice the angle at circumference. Okay, now let's look at the next sum. Now look at 8 part B. Now O is the circumcenter of the triangle ABC that's given to us. The vertices of this triangle lies on the circle, okay? And AC equals to BC. And angle ACB, which means this angle, is given as 56 degree. They have asked to calculate CAB, which means this entire angle, and OAC, which means this angle. The first thing, in triangle ABC, if you look, ABC, angle CAB will be equal to CBA. Suppose X. Why? Because it's an isosceles triangle. Look over here, AC and BC are equal to. Opposite to AC, you have angle B, and opposite to BC, you have angle A, isn't it? So we can say x plus 56 equals to 180. That's angle sum property, which means twice x equals to 124 if I'm not wrong. Yeah, so x equals to 62 degree, which means angle CAB is equal to 62 degree, as well as angle CBA is equal to 62 degree. So this is 62 as well as this one. Okay, now they told angle OAC. What I'll do, I'll join OC. Okay, now look, angle at the center will be twice the angle at circumference. Angle AOC will be twice angle ABC. Angle at center is twice angle at circumference, isn't it? So angle AOC will be twice of 62, that's 124 degree. Done. Now just last part, just look at triangle AOC. Triangle AOC. OA equals to OC, that's the radius, which means it's a isosceles triangle. If it's an isosceles triangle, this angle OAC will be equal to this angle OCA, suppose Y, then Y, and this is given as 124. So Y plus 124 equals to 180. So 2y equals to 180 minus 124, that's 56. So y equals to 28, which means angle OAC will be 28 degree. Very easy. We just needed to join OC, then use angle at the center is twice the angle at circumference. And this was isosceles triangle property. Clear? Now let us look at the next sum. Now look at 9 part A. They've given a circle. AC is parallel to ED. Angle CBE is 65. Calculate DEC. This angle they want. Now how to get this? What I'll do a construction. I'll join AE. Join AE. Now look carefully. CBE, angle CBE, look carefully, is equal to CAE, same segment, CAE, that's equal to 65 degree, angle in same segment, isn't it? So we got this as 65 degree. Now look carefully. This AC is the diameter, we know that, okay? That's given. In triangle CEA, angle CEA equals to 90 degree, which means this angle equals to 90 degree. Angle at a semicircle. Angle at semicircle, isn't it? Once you got 90, you can get this angle, isn't it? Suppose this is x. Then in triangle CEA, x plus 65 plus 90 will be 180. Angle sum property, which means x will be 25 degree. Now look carefully. Angle DEC is equal to ECA, which is equal to x. Look carefully. Alternate angle, which is equal to 25 degree. Alternate angle, which means this angle and this angle are same. Alternate. So if this is 25 degree, this has to be 25. Alternate angle. Done. Pretty simple. We use same segment and angle at semicircle property. Okay. Now let us look at the next sum. Now look at 9 part B. Very easy. The circle, O is the center, ACB is P degree, AOB is Q degree. They have asked us to express Q in terms of P and calculate P if OACB is a parallelogram. Very easy. Just look over here. First of all, I need to find this angle, which is reflex AOB will be 360 minus Q. No doubt in that. Now, angle at the center is twice the angle at circumference. See, AOB reflex ACB, segment is same. Angle reflex, I'll say reflex angle AOB will be twice angle ACB. Why? Angle at center is twice angle at circumference. We need to write the reason. So this is 360 minus Q. So 360 minus Q is equal to 2P, isn't it? So we can say, you can leave the answer like this also, or make Q the subject. So 360 minus 2P equals to Q. Done? Okay. Now the second part. Calculate P if OACB is a parallelogram. Now, if OACB is a parallelogram, opposite angles are equal, which means Q will be equal to P, isn't it? Which means instead of Q, we can put P over here, which means 360 equals to 3P, which is P equals to 120 degree. Done. Pretty easy. Okay. Just used one property, that angle at the center is twice the angle at circumference, and the rest was parallelogram property. You know that opposite angles in a parallelogram are equal. Now let us look at the next sum. Now look at this sum, very easy. 10 part A. In a circle DEB, means DB and AB are straight line. Okay, O is the center. Okay, which means DC is the diameter. OCE, angle OCE is 40 degree. AOD is 75 degree. They have told us to calculate CDE, CDE, which means this angle, pretty easy, and OBE, this angle, very easy. First of all, look at triangle CDE, over there. This angle has to be 90, angle of the semicircle, because CD is the diameter. Angle CED is equal to 90 degree. Angle at semicircle, isn't it? Once you got that 90, this is 40, you can calculate this angle CDE plus 90 plus 40 equals to 180. Angle sum property, which means CDE will be 50 degree. Done. So this is 50. Now look carefully. This angle, if you look at triangle DOB, this angle plus this angle equals to this angle. Exterior angle equals to sum of opposite interior angle, which means I can say angle DOA will be equal to ODB plus DBO. So angle DOE is 75 degree equals to ODB 50 degree, and DBO I can write OBE, there's no issue, same angle, which means angle OBE will be 25 degree. Done. Pretty easy. We just used angle at the semicircle property, and then angle sum property, and then exterior angle equals to sum of opposite interior angle. Done. Okay. Now let us look at the next sum. Now look at this sum, 10 part B. In this figure, I is the in-center of triangle ABC, which means with I, if I draw a circle, I know it's not perfect, but still, you know. So I is the center for this circle in such a way that it touches the three sides of the triangle. Okay, and if you join, you know, this, then AI, BI and CI are bisector, remember, bisector of angle A, angle B and angle C respectively. We know this. Okay. Now look carefully. What they've given. AI produced meet the circumcircle. Now ABC has a circumcircle also. That's an incircle, that's a circumcircle, which means it passes through the vertices, okay, the circle. At D, given angle ABC is 55, which means in this triangle, this angle is 55. Angle ACB is 65. Calculate BCD. BCD, which means if you look carefully, this angle, CBD, this angle, DCI, DCI, this angle, and BIC, BIC, this angle. First, this part. Okay, first of all, angle BAC plus 55 plus 65 will be 180. Angle sum property, just look at triangle ABC. In triangle ABC, these two angles are given. So this angle, this is 55, this is 65. So angle BAC will be 60 degree. Done. Now we know AI is the bisector of angle A. So angle BAD will be equal to DAC. Angle DAC will be equal to 60 by 2. That's 30 degree. I mean this angle and this angle will be 30 degree each, isn't it? Because AI is the bisector. Now look carefully. BAD, angle BAD and angle BCD will be same. BCD. This angle and this angle has to be same. Angle in the same segment. That's 30 degree. Same segment. Clear? Similarly, if you look at CBD and CAD, angle CAD is equal to CBD will be 30 degree again. Same segment. Angle in same segment. They have to be equal, isn't it? So this is also 30. Okay. Now they have asked for, the first two part is done. Okay. Now they have asked for DCI. Okay. BIC. First of all, look at BIC. Okay. In triangle, just look. In triangle BIC, angle IBC will be 55 by 2. 55 by 2. Why? Because BI is the bisector of angle B. That's 27.5 degree. Okay. Similarly, ICB is equal to 65 by 2. Because IC is the bisector of angle C and angle C is 65. So that's 32.5 degree. Therefore, angle BIC will be 180 minus these two angles, isn't it? Which means 180 minus this is 30, 40, 50, 60 degree. That's 120 degree. So this is also done. 120 degree. Clear? Now look at DCI. DCI. Now how to find DCI? This is 30. Done too. This portion, see, angle DCI, if you look carefully, okay, angle DCI is made up of angle DCB plus BCI, angle BCI, isn't it? Now DCB is 30, look carefully, and BCI, we just got BCI is 32.5 degree. So that's 62.5 degree. Done. DCI and BIC we have already got over here. If you can draw the diagram, use the property, draw the incircle, try to visualize the property of an incircle that, you know, AI, BI and CI will bisect the respective angles, angle A, angle B and angle C. Then your work will be easier. Clear? Now let's look at the next sum. Now look at sum number 11. Very interesting. They have not given the diagram. O is the circumcenter of triangle ABC. So if you have a circle, okay, then just look. I'll draw a triangle OBC. O is the circumcenter of the triangle ABC. D is the midpoint of BC. So D is the midpoint of BC, which is BD and DC is same. Prove that angle BOA, which means if I join this, then this angle is equal to this angle. Very easy. First of all, try to prove that these two triangles are congruent. Our work is done. Look carefully. In triangle BOD and triangle COD, just look. OD equals to OD, that's common, isn't it? OB equals to OC, that's the radius, has to be equal. And BD equals to DC, because D is the midpoint they have given, is the midpoint, which means triangle BOD is congruent to triangle COD, isn't it? Now once we prove congruent, we can say that angle BOD will be equal to COD, and these two angles are equal. Now look carefully. Angle BOC will be twice of angle BAC. Angle at the center is twice the angle at circumference. Angle at center is twice angle at circumference. Now look, instead of BOC, can I write twice of BOD? Twice of BOD, because these two angles are same. So instead of the entire angle, I am writing BOD 2 times. This is equal to twice. BAC is nothing but angle A. Look carefully. Which means angle BOD is equal to angle A. Pretty easy. Clear? In this video, keep it till here. In the next video, we'll do the rest of the sum from this exercise. Till then, take care.